The creation of a plant or a machine is typically a project that comprises 4 different phases. First, planning and configuration. Second, implementation and module test. Third, testing and commissioning. Fourth, operation and maintenance. The optimal interaction of all programming tools and functions involved in the project enables a high plant and manufacturing quality, as well as reducing the commissioning and operating costs. The basis is the Simatic software, which supports you in all phases of the project. The ideal case would be a Simatic programming device with all the desired Simatic software readily installed for instant use to accompany you throughout the project. But of course, the system environment for the software can also be a Siemens industrial PC or standard PC. Depending on the size and type of the automation components used and on the automation task in hand, the programming tools can be combined from a wide range of available software packages. The Simatic Step 7 professional engineering environment contains a sizable basic package for dealing with complex automation projects. This engineering suite can be expanded by optional software packages, for instance for the configuration of operator control and monitoring systems, or for dealing with technological tasks. The necessary software packages, such as WinCC Flexible or S7 technology, integrate smoothly into this suite. You can choose from many more software packages that integrate just as easily and allow you to customize your development environment perfectly to the project requirements. Having a lot of specialized tools does not in itself guarantee an optimum solution of an automation task. What matters is that they interact smoothly. The Simatic Manager supports you in processing your projects by integrating all these tools and functions into a consistent development environment. Structurally, the Simatic Manager consists of a number of powerful tools for project processing, such as the hardware configuration, the network configuration, editing the symbols, the various testing and commissioning functions, as well as archiving the project data. Furthermore, the Simatic Manager manages the editors for program generation, as well as the optional software packages such as the programming languages S7 SCL or S7 Graph, operating and monitoring systems such as WinCC Flexible, or runtime software such as PID Control, only to mention a few. A decisive factor for a time-optimized configuration process, in addition to the comfortable operation of the software tools and functions, is clear and consistent data management throughout the configuration. This means in practice that the user runs one tool after the other as the project evolves, and uses a continuously growing database in the process. The tools used can access this database at any time, so that project data, such as the symbols used in a project, can be used by all the tools once they have been entered. In this way, double data input and inconsistencies are avoided. We will now show you what the project data look like in the Simatic Manager as seen by the user. The entire automation system is organized in a hierarchically structured project, whose function is the organized storage of all data and programs generated in the course of solving an automation task. All the objects handled by the Simatic Manager have an equivalent in the real objects of the plant. A project comprises mainly the following hierarchically structured objects: one or more stations containing all the data of a controller. This, on the one hand, includes the configuration data with the station's hardware structure and the parameters of the modules used, and on the other hand, all user program data contained in the CPU object. The CPU object has the connections of the CPU assigned to it, and the S7 program contained in the CPU. As to the S7 program object, it contains the symbol table, the program source folder, and a folder containing the user program blocks with the executable code. By means of this hierarchical project structure, the data generated in different areas of the project are assigned clearly and easily to the associated objects. These can, of course, be changed on demand. In multi-user mode, multiple users can edit a project at the same time. In Phase 1, Planning and Configuration, we create a project containing a station, set up the hardware, and configure the connections. We generate a new project via the File menu, stating the storage location and the project name. We add to the project a station, in our case a Simatic 300 station. The station contains a hardware object which we open by double-clicking, starting the Hardware Configuration tool. In this tool, the hardware is configured to reflect the actual hardware structure. All available modules are contained in the hardware catalog, which can be updated through the Internet if required. Even third-party modules can be integrated into the catalog by means of manufacturer-supplied GSD files. The hardware configuration process assigns to each module a slot, a unique address, and parameters. If these are manually assigned, the Simatic Manager checks the module addresses and parameters for plausibility and consistency. The basis of all communication within a plant or machine is a configured network. The Network Configuration tool represents all configured connections graphically and allows you to create and configure new connections. This applies both for communication with the distributed I/O and for communication between the Simatic stations. In Phase 2, Implementation and Module Test, we create the symbols, develop the control program, test it for the first time module by module, and configure the visualization function. First of all, each operand used is assigned in the symbol table a comprehensible name that matches its task. This symbolic name can then be used in the program, which makes it much easier to understand. The name will also be used by the operator control and monitoring software. Furthermore, a comment can be added to each symbol to describe its task in more detail. The symbol table can be revised and updated at any time as the program evolves. The block folder contains the user program. This includes, for instance, the system data with the configuration and communication data, as well as all executable blocks containing the control program and the user data. The resulting user program is composed of the individual program blocks. You select for each block the programming language that is best suited to the task in hand. The appropriate editor is started automatically. For the module test, the S7 PLC SIM simulation software is available. It allows you to test the user program offline without having to transfer it to the real-life plant. S7 PLC SIM simulates to a certain extent the station configured in the project. This includes, for instance, loading the user program into the CPU. The simulation contains input modules at which binary signals are controlled, or digital values entered. The results can be read, for instance, at the simulated output modules. This allows you to check the correct functioning of most of the program without leaving the office. Likewise, the development environment of the operator control and monitoring system, for instance WinCC Flexible, is integrated throughout into the Simatic Manager. Like all other integrated tools, the configuration software for the visualization function is started from the Simatic Manager. It accesses the central data pool of the Simatic Manager and stores its own visualization data in that pool, so that they are available for the other tools. Phase 3, Testing and Commissioning, includes loading the program into the controller, testing it during operation, and archiving and backup of the project. After building up a connection between the programming device and the station, we load the user program into the CPU. With one click, the Simatic Manager shows us the CPU's online program. A wide range of test tools is now available for quick and comfortable commissioning, including monitoring and control of variables, forcing of variables, program status, single-step mode with stop points. These tools provided by the Simatic Manager allow you to modify the program during operation and to see immediately what impact your corrections have on it. After commissioning, but also in between to back up your data, you can compress and archive the entire project with all its programs and data. It can also be stored in the CPU in this format. Phase 4 of an automation project is operation and maintenance. Here the Simatic Manager assists you, for instance, with its teleservice tool. The teleservice option package establishes an online telephone connection with a remote plant, thus allowing you to perform remote diagnosis of that plant. In this way, you can monitor at any moment what is going on in the remote plant and even, with all due caution, influence it. Likewise, the teleservice software allows you to change the user program at any time. Summing up, we will give you once again an overview of how the Simatic Manager accompanies you throughout all the phases of an automation project. In the planning and configuration phase, you create a project and configure the hardware of the automation device, using the hardware configuration and network configuration tools. In the implementation and module test phase, you use the various programming languages and the simulation software to generate your program and run a preliminary test on it. Testing and commissioning are performed reliably and in good time using the extensive test and diagnostic functions. In the operation and maintenance phase, you can check your machine or plant at any moment over the telephone network. All this makes the Simatic Manager an individualized toolkit that provides you with optimum support in all your automation projects.